Hello everyone, I am Yadav from KANAL'S. Welcome to you all. We have already started with solid state. Okay, so in the solid state, we will now do magnetic properties. We know that solid, not all, but some solids do show magnetic properties. We'll discuss why they show the magnetic property and what type of magnetic property do they show. In the previous class, we have completed some of the numerical questions based on packing, density, coordination number, and other topics related to this. Now we'll be starting with the magnetic property. Though the magnetic property topic is very small and very easy, but sometimes MCQ and give reason question asked from this topic. And what are the questions we discuss in that topic? Magnetic property as a word suggests some of the magnetic property. Magnet क्या होता है? The magnet is something which attracts the magnetic substance towards itself. You already know about this, right? So why solid is showing the magnetic property? That is our first question of discussion that we want to know. We say that if in a solid electrons which is available, electrons revolve around itself and around the nucleus. So mainly the magnetic property is due to revolving of electrons. Electrons are charged particles. So when they are revolving, they will create a magnetic property. Okay. So due to electron, magnetic property will be seen in the solids. Though the value would be very small, but if we combine the electron obviously, it do show the magnetic property. So now we have studied why solid shows magnetic property. Not all, but yes, some solids do show magnetic property. Types of magnetic property, if we say types of magnetic property would be paramagnetic, dimagnetic, ferromagnetic, antiferro, and ferrimagnetic. But in your syllabus, you have only 3: para, di, ferro. Other one we will discuss when we do the entrance part. So in entrance part, we will discuss about all the magnetic property. But in today's class, we'll discuss about only 3 magnetic property. Okay. चलिए सबसे पहले we'll start with the paramagnetic property. That will say paramagnetism in short. So we say that paramagnetic substance, what are they? If we keep the paramagnetic substance in between the two magnets, paramagnetic substance is a solid substance. If they attract the magnetic field, we will say that it is paramagnetic substance. So they are magnetized in a magnetic field, the same direction. They lose their magnetism in absence of magnetic field. So can I say they are sometimes act as a temporary magnet? So in presence of magnet only, they will have their magnetic field. For example, oxygen, copper, iron, and so on and so forth. Generally, paramagnetic substances have very less number of unpaired electrons. So unpaired, due to the presence of unpaired electrons, they attract the magnetic field. So वापस paramagnetic substance show presence of unpaired electron. Due to presence of unpaired electron, they attract the magnetic field. But as soon as you remove the magnetic field, then magnetic property also goes. Okay. Look, magnetic property I'm trying to say, then magnetism. Magnetism means that if we keep a magnet and iron for some period of time, till that it is attaching with the magnet, it will show magnetic property. But as soon as you remove the magnet, iron won't show any magnetic property. So वापस वही है, magnetism use कर देगा अगर हम magnet उसके आसपास उसको निकाल देंगे. It was all about paramagnetic substance. वापस क्या ध्यान रखना है? Paramagnetic substance, unpaired electron होंगे, attract the magnetic field. बात हो गई खत्म. ठीक है. आगे we'll talk about dimagnetic substance. In case of dimagnetic substance, if we keep between the magnetic field, they repel the magnetic field. The reason for repelling the magnetic field is simple. They all are paired. Okay, so they are paired, they don't attract the magnets. So as they are paired, they don't attract the magnet, therefore they repel it. ठीक है, क्योंकि हमें पता है कि इलेक्ट्रॉन क्या या तो either can be electron in a single or it can be paired. here. So as they are paired, they repel the magnetic field. So diamagnetic substrates are the substrates which repel the magnetic field when kept in the magnet between the magnets. They all are paired substrates. The electron which is there, they are paired. Because they are paired, so they cancel out each other's magnetic field. They cancel out each other's magnetic field. ठीक है? लॉजिक क्लियर है? क्या इसमें कोई भी अनपेयर्ड इलेक्ट्रॉन डायमैग्नेटिक सब्सटेंस में नहीं प्रेजेंट होगा. They all cancel out each other's magnetic field. Next, and the important one on which give reason question has been asked many times is ferromagnetism, that is ferromagnetic substance. So ferromagnetic substance, what are they? They show various, higher number of unpaired electrons. What is ferromagnetic substance? Which shows larger number of unpaired electrons. First point याद रखना. तो अगर ज्यादा नंबर ऑफ अनपेयर्ड इलेक्ट्रॉन्स होंगे तो अट्रैक्शन भी क्या होगा, ज्यादा होगा. तो स्ट्रांगली मैग्नेटिक फील्ड को अट्रैक्ट करेगा, तो इसको ही हम बोलेंगे फेरोमैग्नेटिक सब्सटेंस. वापस, जितने ज्यादा अनपेयर्ड इलेक्ट्रॉन होंगे उतना ज्यादा मैग्नेटिक फील्ड को अट्रैक्ट करेगा. फेरोमैग्नेटिक सब्सटेंस ही वही सब्सटेंस होते हैं which we use as a permanent magnet. Paramagnetic substance can be used as a permanent magnet. याद रखिएगा. डाई में क्या था, मैग्नेटिक फील्ड को रिपेल करेगा. सारे पैड, सारे अनपेड, बहुत सारे लार्जर नंबर ऑफ अनपेड इलेक्ट्रॉन, तो दे विल अट्रैक्ट द मैग्नेटिक फील्ड. हम फेरोमैग्नेटिक सब्सटेंस बोलेंगे. सो जिधर भी इलेक्ट्रॉन स्पिन हो रहा है, मतलब दे रिवॉल्व अराउंड इटसेल्फ एंड around the nucleus, तो एक डोमेन बनता है. तो it acts as a tiny magnet. In an unmagnetized piece of ferromagnetic substance, the domain are randomly oriented and their magnetic movements get cancelled. अगर ये जो है, अगर देखो ये, we are giving you the introduction about the anti-ferromagnetic substance. So if all the unpaired electrons are arranged in such a way that if they cancel out each other, they won't show any kind of magnetic property, but we will see this part in the anti-ferro and ferrimagnetic. For अभी के लिए just simple, ferromagnetic substance, larger number of unpaired electrons strongly attract the magnetic field if they keep in between the, if we keep them in between the magnetic field. The substance is placed in a magnetic field. All the domain electrons which I am talking about get oriented in the direction of magnetic field. Strong effect is produced. This ordering of domain persists even when magnetic field is removed. What we have saw electrons, they are arranged themselves randomly. So if they are placed randomly, they may cancel out each other magnetic field. If we keep it in between the magnet, they'll arrange themselves in a particular pattern and show magnetic field even after we remove it. I want you to compare this between the paramagnetic substance and the ferromagnetic substance. Para में क्या था? In a paramagnetic substance, if we remove the magnetic field, they lose their magnetism. In ferro, which is not the case. If we remove the magnets, if we remove the magnets, they will still show magnetism. Okay, fine. Give reason when question is generally being asked. Why Fe shows why Fe shows ferromagnetism? This is a give reason question. It's been many times asked. This is for the homework. You need to find out. For that, I'm giving you the hint. You need to write Fe ka electronic configuration and see how many unpaired electrons it has. What would be that? You can answer. In Fe ka configuration, which is Z equals to 26, argon 3d6 4s2, there will be 4 unpaired electron. I'm helping you. There will be 4 unpaired electron. So because you have to write, because the number of unpaired electron is more, they will show ferromagnetic property. They will attract the magnetic field when kept in between the magnets. Fine. So this type of ferromagnetic question has been asked in a previous year. But yes, you can compare this part when you teach, when we learn the transition elements, we'll discuss about this again, but still. Okay. So we have talked today about So we have discussed today about magnetic property, why some solids do show magnetic property. Then we have talked about paramagnetic, diamagnetic, and ferromagnetic. Okay, I'm hoping that you understood the topic. We'll discuss more topics regarding the solid state, its defects present in the solid in the next class.